we want to take a look at the graph of the sine and the cosine function, and we're going to start with the graph of the sine function. Now, before we can get there, we have to talk a little bit about the theory of functions. What's actually happening here? So the idea, let me make that a little bit smaller. The idea is that we have some input variable, theta. We're going to do some sort of process, and we're going to get some output value, sine of theta. So typically, this is x and this is y. In this case, we're using theta and sine theta because we're specifically talking about this function. And this little squiggly arrow here is just saying that there is some rule, some process, something that we do to this input value that leads us to the output value. And so the question is, what is that process? Well, theta, if we put it in standard position, like this, remember that the definition of sine of theta is related to some point x comma y on the plane. And we can draw a circle of radius r, and that gives us the formula sine of theta is equal to y over r. Right, so this is the basic picture. Now, in particular, since this works for any circle, we might as well pick the unit circle because that's one we want to work with. Set r equal to 1, that makes our denominator equal to 1. And then the sine value is just the y coordinate. And there's a graphic that you can use to sort of demonstrate this even more clearly. But what's going to happen here is that we take this value of theta, and it corresponds to some point on a grid. So here's our theta coordinate, and here's our sine theta output. So what's going to happen? So for this value of theta, let's just say that that's this point right here, we get a particular y value. So this y value right here is the same as this y value right here for that specific value of theta. As you change the value of theta, the picture over here changes, which changes the y value. The height gets bigger and smaller depending where it is, or even negative on some parts of it. And that corresponds to points over here on the graph. So a few of the key points to keep in mind are that when the angle is 0, the y coordinate is 0. When the angle is pi over 2, the height is 1. At pi, the y coordinate is 0 again. And then at 3 pi over 2, the height is negative 1, right? The y value is negative 1. So 3 pi over 2 would be a negative 1. And then at 2 pi, let me just squeeze this in. At 2 pi is the same as 0 and goes back to 0 again. So the shape of the graph, this is going to be not a great graph, but it looks something like this. And of course, we can make this more clear by using computers and things like that. But this is the idea. When we're looking at the graphs of these functions, we have an input value. There's some process that we use to calculate what the output value is going to be. And then we can graph that, x comma y, input value in the horizontal direction, output value in the vertical direction. And so this is a rough sketch of it, and we'll actually take a closer look at those values in a moment. So here's how we understand the key values of the sine function. Here's our circle, or unit circle. Here's the corresponding graph. And the key values we want to think about are actually the values where this function is either at the middle, which in this case is at the y equals 0 line, at its maximum or its minimum. And these are just values that we can get by thinking about this picture. We always ask yourself the question, what is the y coordinate at this particular angle on the unit circle? And so when the theta value is equal to 0, we are at this point right here, the point 1 comma 0. The y coordinate is 0, and so that's why it starts at 0 here. And this is the midpoint. This is actually the what we'll call the midline in a moment. That's where this graph crosses that midline. The next key value is when we get to here, the peak. That maximum value happens. The value is equal to 1 because the coordinate, we're on a unit circle, is 0, 1. And the theta value is pi over 2. When the theta value is pi, we're back at 0 again. Y equals 0. The y coordinate is equal to 0. And then the 3 pi over 2, the y coordinate is negative 1. And so this chart down here captures all that information. We have the theta values, the increments of pi over 2. That sort of gets us starting from right, up, left, down, and then right again. So 0, pi over 2, pi, 3 pi over 2, 2 pi. And we just want to think about the y coordinates. In this direction, the y coordinate is equal to 0. In this direction, the y coordinate is 1, 0, negative 1, and 0. And that gives us these values. We want to go through the same process except with the cosine function. So once again, we're going to start with some angle theta. We're going to do some process and end up with cosine of theta. That process is going to be taking the unit circle, drawing our angle theta in standard position, getting some point, and in this case we want the point to be we want the value to be the x coordinate. So cosine theta is equal to x. Remember that we set r equal to 1, so x over r, that r is 1, so it's just x here. And this will also lead us to a graph. And so when we think about this, we do need to think back through those key values. And so we are going to think sort of in terms of the being at the mid and the max and the min, except this time we need to think about the x-coordinate. We need to actually think about the horizontal distance. So when theta is equal to 0, we're at that point, the x value is equal to 1. So it's going to start like this. Let me make our chart of key values. So 1, 2, 3, 4, and 5. We're going to have some theta values, and some cosine theta values. Right, so when theta is equal to 0, we're going out horizontally, cosine theta is equal to 1. The next key value happens at pi over 2. When we're at pi over 2, the x-coordinate is equal to 0. We're along the y-axis, which means the x-coordinate is equal to 0. So at pi over 2, we're going to be here. The next one happens at pi. And we can see that the x-coordinate here is going to be -1 because we're going to be as far left as possible. The next one is 3 pi over 2, which points straight down. Pointing straight down, the x-coordinate is equal to 0. I forgot to graph this one, so at pi we have -1, and then 3 pi over 2, 0 again. And then the last one is at 2 pi, and the x-coordinate is once again 1. And so the shape of the graph looks like this. Right, so it's the same idea, same general process, except that when we're setting up this picture, we're now focusing on the x-coordinate rather than the y-coordinate. So this length here at theta equals 0 translates to that height up there. So this is the chart of key values for the cosine function. It starts at the maximum, then it goes mid, min, mid, max. And so if we were to try to graph this, remember that our key values happen at intervals of pi over 2, so pi over 2, pi, 3 pi over 2, 2 pi. We would start at the max, which is 1, then the mid, then the min, which is -1, the mid, and then the max again. So it starts off looking like this. Now, one thing about these graphs to think about is the fact that these functions can continue onward. As we pick bigger values of theta, we continue to wind ourselves around the circle. In fact, we can pick negative values of theta and wind around our circle backwards. The sine and cosine functions are what are known as periodic functions. Periodic functions are functions that repeat after a certain amount of time. And if you think about going around a circle, every time you get back to the theta equals 0 value or something that is coterminal to that, you repeat the same cycle over and over and over again. So even though we only sketch this part of it, because we know the function is periodic, we actually know that it's going to continue the pattern this way, and it's going to continue the pattern this way. And we can, in fact, use the fact that we know that these key values happen at intervals of pi over 2 to know exactly where the next one happens. So if we go forward, the next one is going to be, well, this is 4 pi over 2, so the next one will be 5 pi over 2. The min will be at 6 pi over 2, which is 3 pi, and then 7 pi over 2, and then the max at 8 pi over 2, which is also 4 pi. And you can go backwards. This point right here is going to be negative pi over 2. This down here is negative pi. This is negative 3 pi over 2. And this one's going to be negative 2 pi. Right, so as long as we're stepping in increments of pi over 2, we are following this pattern max, mid, min, mid, max. So this sort of up and down pattern. And that up and down pattern is basically what we want to think of when we have these sine and cosine functions.